Okay, today I'm going to be talking about hydrocarbons. And the name of a hydrocarbon is a bit like a code. It can tell you a lot about the formula and the structure of the hydrocarbon. Now, there's two main types of hydrocarbon that you'll come across at either GCSE or IGCSE level. They are the alkenes and the alkanes. Now, any hydrocarbon that is an alkene will have the ending ene, hence alkene, ene. What that means is there's somewhere in the molecule there's going to be a double bond between two carbon atoms. And the alkanes have the ending ane, ane, which means there's going to be no double bond between the various carbon atoms. And then you can go on to the, and then somewhere in the name of the molecule, you'll get something like meth, eth, prop. For example, propane is a 3-carbon chain, propane, and it's got no double bonds. Okay, now there's 5 that you'll come across at GCSE or IGCSE level, and the first 4 make no sense. The 5th one makes sense, and then after that they do make sense, but you don't really need to know about them for GCSE or a GCSE level. So the first one, methane, so it's got the prefix meth, has 1 carbon in the chain. An eth, 2 carbons, for example methane. Prop, 3 carbons, for example propane, propene, etc. Bute, 4, as in butane and butene. And you've got pent, which is 5, so you have pentene or pentane. Now, there's one other little thing. If in the name of the hydrocarbon you've got something like, if you've got ol, that means there's going to be an OH group in there as well as the hydrogens and carbons. So, just a little example, propane, P-R-O-P-A-N-E, we know it's got 3 carbon atoms. So, just remember that each carbon atom has got 4 valencies. It's got 4 little arms that it can bond to other things with. Okay, so we know that these are all bonded like that. And now the only other thing in methane is hydrogen. So all we need to do is fill the spare bonds of the carbon atoms. Hence we've got, this carbon atom's got 1 bond, so it needs 3 more bonds. Hydrogen's got 1 bond. And that's easy. 3 hydrogen atoms are attached to this carbon atom. Okay, this one in the middle here, the carbon atom, that's already used up 2 of its 4 bonds. So it's got 2 bonds left to use up. So that's 2 hydrogen atoms. And again, the carbon atom on the end is pretty much the same as the first carbon atom. It's got 1 bond used up out of 4, 3 bonds left, 3 hydrogen atoms. Okay, and that is the structure of propane. Now, when you get onto more complicated carbon chains, such as butane, butene, pentene, that kind of thing, then you'll get what's known as structural isomers. Not to be confused with isotopes, they're completely different things. Structural isomer means it's got the same chemical formula, but a different structure. So, if we have a look now at butane, which we know has got 4 carbon atoms. So always draw the carbon atoms in first. Okay, and as I said earlier, this one's got 4 possible bonds. 1's used up, so here we've got 3 hydrogen atoms. The ones in the middle, these 2, they've used up 2 of their bonds, so they can have 2 hydrogen atoms. And the one on the end, it's used up 1 bond, it's got 3 bonds left, so that's 3 hydrogen atoms. Okay? Now, butane, we can work out from this the chemical formula. Well, there's four carbon atoms for a start, so that's going to be C4. Now, hydrogen atoms. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen atoms. So that would be H10. So the chemical formula for butane is C4H10. Now, we've seen one structure, but for the same chemical formula, you can get a different structure. For example, got carbon, 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 arranged like that. That's not very clear. There, carbon. And then you can start working out the hydrogen atoms. So this one's got 1 bond, 3 bonds spare for hydrogen. That one's got used 3 bonds, it's got 1 bond spare for hydrogen. That one's used 1 bond, 3 bonds spare for hydrogen. That's used 1 bond, so it's got 3 bonds spare for hydrogen. Now, if we count that up, we'll find that we've got 4 carbon atoms, C4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. So it's the same chemical formula, but a different molecular structure. Okay? And the same thing applies with things like, it won't work with anything below prop, because there aren't enough carbon atoms to rearrange. But things like butane, pentane, octane, things like that, it will work for. It also works for the alkenes. But again, that's a bit more tricky in terms of calculating the hydrogen atoms because you've got the double bond to contend with. So, for example, butene, we know for a start it's got 4 carbon atoms. 1, 2, 3, 4. We also know that one of those carbon atoms has got a double bond, and that's written like this. And then the others have got a single bond. Now, when we're counting up the spare bonds for the carbon to use up, it gets a bit tricky. Because now both this carbon has already used up 3 bonds, and so this one used up 3 bonds. So these two have only got spare for 1 hydrogen bond. This one on the other hand has got enough space for 3 hydrogen bonds, and the same applies for the other end. So that's the one of the structures. The structure for butene. Now, this one doesn't have any structural isomers. Yes, it does. This is but2ene. Because the double bond is on the second bond. Now, you always count from the side which will give you the lowest number. And in this case you've got 1, 2, and if you try to count from the other side you've got 1 and again 2. So it doesn't matter which way you count from. But on the other hand, if you were to have another carbon atom and then again more hydrogens, you'd end up with, this is pent2ene. Okay, that's pent-2-ene. Here we've got 5 carbon atoms, hence the pent. We know it's got a double bond because it's got the ene, so it's an alkene. And we know that it's pent-2 because if we count the number of bonds in, that's 1, 2. We know we count from the left in this instance because if we count from this end, 1, 2, 3, 4. That would end up as but-4-ene, which is completely wrong. But-4-ene does not exist. Sorry, pent-4-ene does not exist. That would end up being pent-4-ene, which doesn't exist because we've counted from the side which will give us the largest number. What we should have done is count from the side with the shortest number to ascertain the shortest number, hence but-2-ene, so count from the left. On the other hand, if the double bond was here, we would count 1, 2, 3, 4, or 1, 2, 3, 4. You can clearly see from here that by counting from the left, as we did before, we would ascertain the higher number of but-3-ene, which doesn't exist. So we count from the right to get but-2-ene. This is exactly the same molecule which we drew before, pent-2-ene and pent-2-ene. Doesn't matter whether the double bond is in position 2 from the left or position 2 from the right, because if you imagine the molecule could easily be flipped and it would be the same molecule. Okay, now there is another way of writing the structure, or the structural. There's another way of writing the structural isomers for hydrocarbons. Now, what I've shown you before, just now, for writing them, is the visual way of writing them, and there is a simpler. Well, some people find it harder, some people find it easier way of writing the carbon, the structure. So if we start off with something simple such as butane. Now if we remember but, meaning we've got 4 carbon atoms in a chain, and ane, meaning there's no double bond to contend with. So I'm going to write it the visual way, first of all, the pictorial way, and then I will show you the other way, which can sometimes be a lot easier, quicker to write. So, first, always start off by drawing your 4 or however many carbon atoms you have in the chain. So here we've got 1, 2, 3, 4. We know they're all single bonds because it's an ane, and then we can draw in the hydrogen. Atoms. Okay, that's how you do it pictorially. Now, to do it is quite often a simpler way, although some people find it harder. So, for example, here we've got CH3. So we write CH3, first one. And then here we've got CH2, CH2, and CH3. Okay, that is quite often a lot simpler and easier to understand with a great big picture. Or some people find it hard. Everyone likes it different, prefers to learn or write things differently. However, in an exam situation, you might actually be asked to do it pictorially, or you might be asked to do it that way. And as you can see how it relates, this part here relates to that part there, and going along, that part there relates to that part there, that part there relates to that part there, and so on. And as you can see, each part relates to that way of writing to that way of writing. It's a lot more time consuming to do it pictorially, but you can actually visualise how the molecule looks